Ancient Greeks, Romans, and other cultures observed patterns of stars in the night sky called constellations. They imagined that these constellations represent mythological characters, animals, or other familiar objects. Hi, and welcome back. In today's science episode, I will talk about stars. Stars. From Earth, a constellation looks like spots of light arranged in a particular shape against the dark night sky. Let's analyze the illustration. The stars in Orion, a constellation, appear close together, but they really are many light years apart. So from we view it on Earth, apparently they are close together, but in reality, they are far away from each other. Modern constellations. Modern astronomy divides the sky into 88 constellations, many of which were named by early astronomers. Let's take a look at one of them, the Big Dipper, which is here. In red is part of the constellation Ursa Major. It is visible year-round in the northern hemisphere. Constellations close to Polaris. Polaris is the brightest star in Ursa Major. They rotate around this star, which is almost directly over the North Pole. Circumpolar constellations. As Earth rotates, Ursa Major, Ursa Minor, and other constellations in the northern sky circle around Polaris. Because of this, they are called circumpolar constellations. The constellations appear to move because Earth is in motion. The stars appear to complete one full circle in the sky in about 24 hours as Earth rotates on its axis. One circumpolar constellation that's easy to find is Cassiopeia. You can look for 5 bright stars form a big W or a big M in the northern sky, depending on the season. As Earth orbits the Sun, different constellations come into view while others disappear. Because of their unique position, circumpolar constellations are visible all year long. Other constellations are not. Orion, which is visible in the winter in the northern hemisphere, can't be seen there in the summer because the daytime side of Earth is facing it. Absolute and apparent magnitudes. When you refer to the brightness of a star, you can refer to its absolute magnitude or its apparent magnitude. The absolute magnitude of a star is a measure of the amount of light it gives off. A measure of the amount of light received on Earth is the apparent magnitude. A star that dims can appear bright in the sky if it's close to Earth, and a star that's bright can appear dim if it's far away. Measurement in space. How do scientists determine the distance from Earth to nearby stars? One way is to measure parallax, the apparent shift in the position of an object when viewed from two different positions. Let's make an experiment to understand the parallax effects. Extend your arm and look at your thumb first with your left eye closed, and then with your right eye closed, as the girl in figure 3A is doing, like this. Place your thumb, close your eye, one of your eyes, and look at it, and then change of eye. So pause the video and do it. What happened? Well, your thumb appears to change position with respect to the background. Now, do the same experiment with your thumb closer to your face as shown in figure 3B. Pause the video and do the experiment. What do you observe? The nearer an object is to the observer, the greater its parallax is. Parallax is determined by observing the same star when Earth is at two different points in its orbit around the Sun. The star's position relative to more distant background stars will appear to change. So, star A, they trace a path from where it's viewed on January, and then they trace a path where it's viewed on July. If scientists know the angle and the size of the Earth orbit, they can calculate the distance of the star. A light year is the distance that light travels in 1 year. Light travels at 300,000 kilometers per second, or about 9.5 trillion kilometers in 1 year. The nearest star to Earth, other than the Sun, is Proxima Centauri. Proxima Centauri is a mere 4.3 light years away, or about 40 trillion kilometers. Properties of stars. The color of a star indicates its temperature. For example, hot stars are a blue-white color. A relative cool star looks orange or red. Stars that have the same temperature as the Sun have a yellow color. Astronomers study the composition of stars by observing their spectra. When fitted into a telescope, a spectroscope acts like a prism. It spreads light out in the rainbow band called a spectrum. When light from a star passes through a spectroscope, it breaks into its component colors. I hope you found this video useful. Thanks for watching, and until the next one, bye!